Hello everybody, I'm Gokulnath from the Crack with Gokulnath YouTube channel. How are you guys? I hope all are doing well. And today we're going to see about projectile motion. So what does it mean by projectile motion? When an object is thrown obliquely near the Earth's surface, it moves along a curved path. Such a type of motion is only called as a projectile motion. This projectile motion is one of the best example of motion in a plane with constant acceleration. It's one of the best example. So let me draw a 2D plane now, which is XY plane now. I'm drawing XY plane. I'm drawing XY plane, guys. XY plane. This is the XY plane. 1 minute, I will extend. This is x-axis, this is x-axis, this is y-axis, and this is origin. We all know that. Now, let me say that object is projected from this origin. An object is projected from this origin. The object is projected from this origin with an initial velocity of u. The object is projected. That means the object moves like this. This is how the path looks. Now, this is the position B. I'm saying like that. Now, what I'm saying is the object is projected from this origin with an initial velocity of u at an angle theta with the horizontal, and it reaches the maximum height and falls down to the position B. This is what happened in the projectile motion. We all know that this scenario shows the example of a projectile motion. Now, please understand this diagram, guys. Now, let me say some terminologies that we need to understand in the projectile motion. Some terminologies. So, what are the terminologies means? We call this origin, that means this O, origin, as point of projection. That means from the position where the object is projected is called as point of projection. We call this origin as point of projection. And we call this angle theta as angle of projection. That means the angle made with the horizontal is called as an angle of projection. And we know that this u is the initial velocity of that object which is in projectile motion, and this is the position B is the position where the object falls. This is what we need to understand, guys. And our next terminology is, we know that this is the maximum height. This represents the maximum height. That means we know that this is equal to maximum height. I am representing it as MAXH. That means maximum height, guys. This represents the maximum height. Now, our next terminology is range. That means horizontal range, guys. The x displacement covered by this particle for the entire projectile motion is called as the range. What does it really mean, guys? The x displacement covered by this particle for the entire motion. What is the x displacement covered by this particle? That is this OB only, the x displacement covered by the particle for the entire motion. This distance between this OB represents the x displacement. So we can say that this OB as range, or we call it as horizontal range, guys. This is what we call it as range. That means x displacement covered by the particle. Understand this. Now, these are all some terminologies that we need to understand in the projectile motion. Now, let me say some parameters, guys. Let me say some parameters that we need to understand in this projectile motion. What are all the parameters? Very simple concept, guys. Let us first start with the x component. Think what will be the, tell me guys, what will be the x component of initial velocity? Think of it. What will be the x component of initial velocity? The x component of initial velocity. I will draw an arrow. This arrow represents the x component of initial velocity. Try to make a note of it, guys. This arrow, the arrow that I know now, this represents the x component of initial velocity, guys, which is equal to u cos theta. U cos theta. Why it is u cos theta? Think of it, guys. This is the x component of initial velocity. Why this x component of initial velocity is u cos theta means If this angle is theta means if we can do the cos theta and multiply with the u, you are going to get this x component of initial velocity. That is what you are going to get. So only I am writing this x component of initial velocity as u cos theta. Now tell me guys, what will be the x component of acceleration? X component of acceleration. I am writing here, see here, x component of acceleration. What will be that? Now think on it guys. What will be the x component means? We know that in the projectile motion, the object is going to move upward only. We know those things. The object is going to move upward only. If the object is going to move upward means, the acceleration acting on that particle will be the acceleration due to gravity. We all know that. So we take acceleration due to gravity in y component only. Does we take it on the x component? No. So there is no acceleration in the x component. So we can say that x component of acceleration is 0. This is what we need to understand here guys. Because there is no acceleration in the x component, that is why I am saying x component of acceleration is 0. Now tell me guys, what will be the x displacement covered by this particle? That means I represent as x now, we know that. What is the x displacement covered by this particle? Think well on it. The x displacement covered by this particle, will be this range. As I earlier told na, the range only is called as an x displacement covered by the particle. That means the distance between this O and B represents the range. So we can say that the x displacement covered by the particle will give us the range. Now we have seen about the parameters based on x component guys. We saw those things. Now guys, let us see the parameters based on the y component. What is the parameters based on y component? I will write here guys, what is the parameter based on y component? I think origin I will write here. Okay, what is the parameters based on y component? Now tell me guys, what will be the y component of initial velocity? This arrow represents the y component of initial velocity. We know that y component of initial velocity means this only represents the y component of initial velocity. Y component of initial velocity, this arrow represents the y component of initial velocity. What will be that equal to? It will be equal to u sin theta guys. U sin theta. This is what we need to understand. Why it is u sin theta? Same as x component. This angle is theta means do the sin theta and multiply with the u. You will be getting this y component of initial velocity guys. That is what we need to understand here. Now this is u sin theta. Now tell me guys, what will be the y component of acceleration? Tell me the magnitude of that. The y component of acceleration, we know that in the projectile motion, the object is going to move upward only. If the object is going to move upward means, we know that the acceleration acting on that particle will be the acceleration due to gravity. We know that gravity acts downward only, but in the projectile motion, the object is moving upward, which means the opposite direction of gravity. So we can say that the y component of acceleration as minus g guys. Minus g. This is what we need to understand. Our next parameter is y displacement covered by that particle. What will be the y displacement covered by that particle? Think well on it. The y displacement covered by the particle. If we find the y coordinate of this position B means, we can find the y displacement for the entire motion. We can find if we find the y coordinate of this position B, we can find the y displacement for the entire motion. So what is the y coordinate of this position B? This y coordinate of position B is 0. Why? Because this position B is located in the x-axis. If it is located in the x-axis means the y coordinate will be 0. That is a basic concept we all know na. So we can say that y displacement will be 0 because the y coordinate of the position B is 0. So y displacement will be 0. These are all some parameters that we need to understand guys. Try to make note of it. Now our next part is some important properties of projectile motion. Some important properties. What is our first property? The first property is time taken to go up is equal to time taken to come down. I'm writing here guys. Time taken to go up is equal to time taken to come down. Time taken to come down. What does it really mean guys? Time taken to go up is equal to time taken to come down. What does it really mean? Means time taken to reach the maximum height is equal to time time taken to reach the ground from the maximum height. What does it mean, guys? What is time taken to reach the maximum height from the origin is equal to time taken to reach the ground from this maximum height. That is what we call as time taken to go up is equal to time taken to come down. That is what we need to consider here. Okay. Very simple concept, guys. So try to make a note of it. Time taken to go up is equal to time taken to come down. What is our next property that we need to understand? In projectile motion, our next property is at the maximum height, the y component of velocity will be 0. The y component of velocity will be 0. That means at the maximum height, the y component of velocity will be 0, guys. Y component of velocity will be 0 in the at the maximum height. This is one of the main point that we need to remember. Okay, if you remember this property means you can able to easily derive all these things. Okay, guys, try to understand these two properties clearly. So at the maximum height, the y component of velocity will be 0. Now we have seen all the things, guys. That means the terminologies, the parameters, and the important properties. And let us move on to our derivations, guys. Let us move on to our derivations. How to derive the time of flight, range, maximum height. Let us start to derive. I'll take my tester. So I will rub this, guys. Time taken to go up is equal to time taken to come down. Now, guys, let us move on to our derivations, guys. How you will be derive first? Let us start with the time of flight, guys. Time of flight. Let us start with the time of flight. Time of flight, guys. This is what we are going to derive first. How to derive this time of flight first? Let us see carefully, guys. So how to derive this time of flight, mates? Before deriving, what does it mean by time of flight? Time of flight means time taken for the particle for the entire projectile motion is only called as a time of flight. That all know. Time of flight means time taken for the particle for the entire projectile motion. That is what we are going to derive now. So, guys, how we are going to derive this time of flight means we are going to use the second kinematic equation based on the y component. That is what we are going to use here. Second kinematic equation based on y component. We use that to find the maximum, to find time of flight. Okay. What is second kinematic equation based on y component? That is y is equal to. This is the second kinematic equation that all know. Half. This is the second kinematic equation, guys. That all know. Y is equal to y component of initial velocity into t plus half into y component of acceleration into t square. This is what we know in the second kinematic equation based on y component. Now we are going to find the time of flight. So for finding time of flight, we need to consider the entire motion only. So, guys, what is the y displacement for the entire motion? That is 0. Now I will evolve it here. 0 is equal to, what is y component of initial velocity? Y component of initial velocity is u sin theta. U sin theta. What is the time taken? That is t only here. Okay. Plus half acceleration of y component. What is the y component of acceleration, guys? That is minus g. Y component of acceleration is minus g into t square. Now tell me, guys, we are going to find the time of flight. So this time, this t only represents the time of flight. Now that is what we are going to find now, guys. That is what we are going to find now, guys. That means this t only we are going to find now. So, guys, now I will say one thing. We know that half into minus g into t square. What does it mean? It is minus gt square by 2. I will write like that. Minus gt square by 2, guys. I will write like that. Okay. Minus gt square divided by 2. This is how the equation will be becoming now. Now, this is what the equation that we got. That means u sin theta into t minus gt square by 2. Now what I am going to do here, guys, now let me take the t common on the both sides. You can see that the t is common on these both two terms. If the t is common means we can take one t outside. That means 0 is equal to 1 t outside means see carefully, guys. Try to focus. So t, when you take one t outside, this whole equation will be becoming t into u sin theta. U sin theta. Because one t I am taking outside minus gt. Sorry guys, sorry, one minute, sorry for that. Gt divided by 2. This is how the equation will be becoming. What I am doing here is, I am just taking the t common on the both sides, because when I take the t common, this is how the equation will be becoming. That means t into whole bracket of u sin theta minus gt by 2. This is how the equation will be becoming. I will take my choppies. Okay. Now guys, this is how the equation will be becoming. Now tell me guys, what are the solution of this equation? What are the solution of this equation? The solution will be either t will be equal to 0. 1 minute, take another chop. Either t will be equal to 0 or u sin theta minus gt by 2 will be 0. These are the two solutions that we will be getting while evaluating this equation, because this is a quadratic equation guys. If this is a quadratic equation, you will be getting two solutions. That is a basic concept we all know. So that we can say that t will be equal to 0 or u sin theta minus gt by 2 will be equal to 0. Now if we say the time of flight as 0, that means t as 0 means, does it make any sense? No. That is stupidity guys. If you say time is equal to 0 means, does it make any sense? No. We can't say like that. So this is wrong guys. This is wrong. We can't tell like this, okay? We can't tell like this. I will rub this guys. Because we should not say like that So that is why I will rub this. Now t is equal to 0. This is not possible. So t is equal to 0. Now focus on this equation guys. That means this u sin theta minus gt by 2 is equal to u. Now here we need to find the time taken. Now I will rub all the things that we wrote earlier. Okay guys. Tell me guys, when you evaluate this equation, what will the time taken? That means what the equation will become means u sin theta will be equal to gt by 2. So when you need the time taken means this will be equal to 2u sin theta divided by g guys. This is what you will be getting when you evaluate this equation. Just a basic concept. That means 2 goes this side means 2u sin theta is equal to gt. So we want t means 2u sin theta divided by g will give us this time taken, and this is what we call it as time of flight guys. Try to understand this. Okay, that means 2u sin theta divided by g will be giving us the time of flight guys. Try to understand this formula and the derivations that I wrote here. Okay guys, try to understand time of flight is equal to 2u sin theta by g. Just make a note of it and understand the derivations. So that means time taken for the entire motion is 2u sin theta by g. This is how we need to remember. Now we have derived the time of flight guys. Let us move on to our range guys. How to derive this range? Let us move on to that. I will rub guys. Try to remember that time is equal to 2u sin theta by g. Okay, I have rubbed all the things guys. Now guys, how you will be deriving the range guys? Range means, how you will be deriving the range means, I will rub this because we are going to derive the range So range, I will write range here. Range. How will be deriving range? Guys, to derive the range, we are going to use the second kinematic equation based on x component. The second kinematic equation based on x component will give us to derive the range. Help us to derive the range. So what is second kinematic equation based on x component? Think well on it. We know that second kinematic equation based on x component is x is equal to plus half. This is the second kinematic equation based on x component. Okay. So when you deal this equation means what answer you will be getting guys. Now evaluate this equation. Now try to make note of it guys. Before evaluating, try to make note of it. We know that this x only will give us this range, because as I earlier told, this x displacement will give us this range. This x distance give us this range means we can say that this x displacement, here also x so we can say that this x will be giving us the range. That is what we need to understand guys. So in behalf of writing it as x, I write it as range, because this x displacement will be giving us the range. Okay, this OB will be the range. So we can say that when you evaluate the equation, what is x component of initial velocity? That is u cos theta. Range is equal to x component of initial velocity u cos theta into t plus. Now see guys, what is x component of acceleration? That is 0 here. If x component of acceleration 0 means this whole term will be 0 now, half ax into t square. This whole term will be 0. So plus 0 means we directly write it as range is equal to u cos theta into t. Because this whole term will be becoming 0 because x component of acceleration is 0. So the range means u cos theta into t. This u cos theta into t will be giving as the range, guys. Okay. Now we are going to do some changes in the u cos theta. What are the changes that we are going to do? Some change in the u cos theta. That means range is equal to u cos theta into t. Now earlier I found what is time taken? The time taken is 2u sin theta by g, time of flight for the entire motion. That means 2u sin theta divided by g. Now use it here, guys. U cos theta into time. 1 minute, guys. 2u sin theta by g. I think I should write here. 1 minute. 2u sin theta divided by g, and this will be giving as the horizontal range, or we simply call it as range. That means what I am doing here, guys, range is equal to u cos theta into t. What's the time taken that we earlier found? The time of flight we have found now, which is equal to 2u sin theta divided by g. We have derived the time of flight. That is what I am doing here, 2u sin theta by g. Now tell me, guys, when you evaluate, what you will be getting is range will be equal to u cos theta into 2u sin theta. We can write it as 2u sin theta 2u square sin theta cos theta divided by g. This will be giving as the range. So just I am multiplying this both terms, guys. That means when I multiply means 2u square sin theta cos theta divided by g. This is what the equation will be getting now. Now tell me one thing, guys. In trigonometry you learned that double angle formula. That means sin 2 theta is equal to 2 sin theta cos theta. That all know. Sin 2 theta is equal to 2 sin theta cos theta. So we can say that here the 2u square sin theta cos theta. You can see that the form like 2 into sin theta cos theta. What does it mean? The double angle formula. This 2 sin 2 theta. Sin 2 theta is equal to 2 sin theta cos theta. Understand this, guys? Sin 2 theta is equal to 2 sin theta cos theta. Okay. So we can say that instead of this 2u square sin theta cos theta, I can write it as see carefully, guys, I can write it as u square sin 2 theta divided by g will be giving as the range. Okay, I will write the formula at the above, guys, because it will be confusing. So range will be equal to u square. That means when I do this means 2 sin theta cos theta means that is sin 2 theta. I am writing like this. The u square is remaining. So u square sin 2 theta divided by g. So u square sin 2 theta divided by g will be giving as the range. That means horizontal range, guys. So understand this. What's the range? U square sin 2 theta by g. So that's all, guys. Now understand the derivations well and better. Okay. So I'll wrap this, guys. Derivations. Okay. So understand that. This range is equal to u square sin 2 theta by g. Okay. So guys, let us move on to our derivation of our maximum height. How to derive our maximum height, guys? Here also, guys, we're going to use the second kinematic equation based on y component. That is what we are going to use here. Second kinematic equation based on y component will help us to find the maximum height. So I will write here, guys, maximum height. I need to take another chalk. 1 minute, guys. Oh yes, guys. Now maximum height, guys. So we are going to use the second kinematic equation based on the y component. So what is second kinematic equation based on y component? That earlier I told now y is equal to, this is second kinematic equation na, half this is the second kinematic equation that we know. Now we are going to derive this maximum height. What is this maximum height? That means the maximum height obtained by this particle while it is in projectile motion. That is what we call it as maximum height. So tell me, guys, we are going to derive the maximum height only. So that is why only we are using this kinematic equation. So we can say that instead of writing this y, we can write it as maximum height itself now. Why we can write like that, guys? Because we are going to derive the maximum height only. If we are going to derive the maximum height means we can write this y as h itself. That means the maximum height. I am representing the maximum height at h, guys. So instead of y, I can write it as h because this y will be giving us the maximum height. So that is why earlier itself I am writing the y as maximum height, guys. Try to understand this, guys. Over with when we are doing the derivation, guys, at last you will understand why this y is equal to h, guys. So make sure that you understand these things. Okay, so we can write this instead of y, we can write it as h. Now tell me one thing, guys. We know that h is equal to what is the y component of initial velocity? What is y component of initial velocity? Y component of initial velocity is u sin theta. Okay, u sin theta, right? Yes, u sin theta into t, guys. U sin theta into t plus half ay. That means half into acceleration. Y component of acceleration. What is y component of acceleration, guys? That is minus g, guys. Minus g into t square. This is what we know. This is what till now we have learnt. Now tell me one thing, guys. We can change this equation as h is equal to u sin theta into t. That means I am just evaluating this equation. This is how the equation will be becoming when you substitute these values. Now we know that earlier we found that the time of flight, guys. Now tell me, guys, this time of what will be the value of this time taken? That means u sin theta into t. What will be the value of this time taken? Now, yes, all will say that the time taken in this situation is, in this kinematic equation is 2u sin theta by g. Yes, all will say like that because time of flight only we are going to apply here. But that is pakka wrong, guys. You cannot say that the time taken here is 2u sin theta by g. Why we can't say that? Means time of flight means time taken for the particle for the entire projectile motion. But here we are going to use the kinematic equation for the maximum height only. So the time taken that we need to consider is from the origin up to maximum height. What is the time taken? That is what we need to consider here. We should not consider the time taken for the entire motion. We need to consider the time taken from origin to this maximum height. So what will be the time taken from the origin to the maximum height? Think of it, guys. What will be that? From the origin to maximum height, the time taken. How you will be finding that? Means, as I told one property, time taken to go up is equal to time taken to come down. If the time taken is to go up is equal to time taken to come down, means we can say that time taken to reach the maximum height is equal to time taken to reach the ground from the maximum height. So the time taken from the origin to the maximum height will be half of 2u sin theta by g. Half of 2u sin theta by g will be giving as the time taken from the origin to maximum height. So what is half of 2u sin theta by g? That is u sin theta divided by g, guys. This will be giving as such u sin theta divided by g plus I think, guys, now we can say that minus half minus gt square. Okay, so I will see carefully, guys. Minus g by 2. I am writing like that because minus g by 2 and half mean half into minus g is minus g by 2, and we can evaluate the time now. What is the time taken for up to the maximum height? That is u sin theta divided by g. U sin theta divided by g whole square, because they are given time square na, so we can say it as this is how the equation will be becoming here. That means u sin theta into u sin theta divided by g minus g by 2 into u sin theta divided by g whole square, guys. Now tell me, guys, what is u sin theta into this divided by g whole square? That is u square sin square theta divided by g square. I can write like that na. U sin theta divided by g whole square means u square, see carefully, guys, u square sin square theta divided by g square. We can say like that na, because u sin theta divided by g whole square means u square sin square theta divided by g square. This is how the equation will be becoming. Now tell me one thing, guys, this g square and g will be cancelled out now, because this 1g and this g will be remaining here. When you cancel out means what answer will be getting, guys? What answer will be getting is just it became as g only, and when you cancel out there will be no, so that it will become as 1. So 1 by 2 into u square sine square theta divided by g, guys. Just I'm doing the basic equation, guys. Just I'm solving this basic equation, guys. So half into this u square sine square theta divided by g, guys. This is how the equation will be becoming. Now tell me one thing, guys. We can say that the height is equal to u sin theta into u sin theta divided by g, which is equal to u sin theta into u sin theta is what? U square sin square theta divided by u square sin square theta divided by g minus half into u square sin square theta divided by g, means we can write it as u square sin square theta divided by 2g. Now guys, this is what this equation will be giving as the maximum height, guys. Just what I'm doing, I'm just evaluating this expression, guys. So when you evaluate this expression, this is what you will be getting. So what answer you will be getting, guys? Tell me, guys, what answer you will be getting? So u square sin square theta divided by g minus u square sin square theta divided by 2g, means we can write it as h is equal to 2u square sin square theta divided by g divided by 2g, okay, 2g minus this u square sin square theta divided by 2g. What I'm doing is I'm just making the denominator common, guys, because when only we can subtract the numerator, na. So that is one the basic thing I'm doing here. So when you do that, the maximum height reached by this particle will be equal to u square 2u square sin square theta minus u square sin square theta, that is equal u square sin square theta. So u square sin square theta divided by 2g will be giving as the maximum height reached by a particle which is in the projectile motion. That means up to the maximum height, what is the maximum height? This distance. This maximum height is equal to h is equal to u square sin square theta divided by 2g, and this is what will be giving as the maximum height, guys. Basic concept, guys. We can see all the things, guys. We have derived the maximum, we have derived the time of flight, we have derived the range, we have derived the maximum height. Now try to understand these things, guys, and try to understand the properties that I told and the parameters. Then you can also derive this, guys. So try to understand these things, guys. If you have any doubts in this thing, please comment me. Try to remember this h is equal to u square sin square theta by 2g. If you have any doubts, means as I told, you can comment me, guys. Very good chapter. Thank you. Make education simple.